Hello. So what we're going to look at now is how do you name alkenes? Alright, same as you do with alkanes, you're going to find the longest parent chain. Alright, so if we're going to go right through the middle here, we can find our longest continuous carbon chain is right through the middle, and so that's going to be our parent chain. The difference though is we want a number from the side that's going to get us to the double bond the fastest. And so if we number from the right, we can get to the double bond in the 2 position. If we'd done it from the left, it'd been 1, 2, 3, and so it's a little bit further. So that's going to be our parent chain. And if you remember, 5 carbons is pentane. And the way we show that there's a double bond is we do the ene. And so I'll just circle the double bond, and it's in the 2 position, so that's why it becomes 2-pentene. Right, and that's for our double bond. Now anything we haven't named as part of our parent chain, we still have to name. So we have our 2 substituents, okay, and 1 carbon is methyl. And remember, methyl, since there's 2 of them, we can use the prefix di. Alright, now we also have to give them a location. And so they're going to be on carbon 3 and carbon 4. Alright, so when we put them as the whole parent chain combined with the substituents, we have to give everything a number. So each methyl group will get its own number, so it's 3, 4, and then dimethyl. And now we put the parent chain, 2-pentene. Alright, so remember, each substituent, whether it's on the same carbon or different, always gets a number. So if you have 3 substituents, you got to have 3 numbers. In this case, we had 2 substituents, we have 2 numbers. And then we also have to give a number for the location of the alkene. On the next one, same idea. We want to find the longest continuous carbon chain that includes the double bond. And it looks like this one's right down the middle. But the one thing you have to be careful about is which of these chains is longer, to go straight across the middle or to go down and over. And I think you'll actually see if we start down the middle, and then when we get to this junction at carbon 5, if you go down and over, you actually get 1 more carbon. Because if we'd gone straight across, we'd only get 7. But since this is one continuous chain, we can keep going through here. So it doesn't matter if the chain goes up, down, zigzags. As long as it's continuous, we can count that as our parent chain. So we get 8 carbons. So if you remember, 8 means octane. And then we're going to change it to ene. Right, with the ene signifying the double bond. Same as before, it's in the 2 position, so it becomes 2-octene. Now what we have to do is identify all the substituents. So we have a methyl group here, another methyl group on carbon 3, and then we also have this ethyl group on carbon 5. Alright, so it's going to be 5-ethyl, and then we'll have the dimethyl again, and it'll be 3,4. Now the thing you have to be careful about is all the substituents get alphabetized. So the question is, which of these go first, the dimethyl or the ethyl? And when you're alphabetizing them, you always go by the root word. So we're going to go by the E from ethyl and the M from methyl. It's really easy to look at it and see the D for di and think that should go before the ethyl, especially if you're just kind of looking at the names like a standardized test or multiple choice. It's really easy that it looks good because it goes D then E. But make sure it's always the root word that you're looking at. So the M versus the E. Alright, so since the ethyl goes first, it'll be 5-ethyl. Three, 4 dimethyl. 2-octene. Alright, so the tricks to this one is kind of 2 of them. Make sure that you truly find the longest carbon chain that contains the double bond. And second of all, make sure you're really careful when you're alphabetizing the substituents that you only use the root word, not the prefixes. Alright, on this last one, Again, it's a little bit tricky because if you look for the longest continuous carbon chain, it's right through the middle here. Now the problem with picking this as our parent chain is it doesn't include both carbons that are part of the double bond. Alright, so both carbons that are part of the double bond have to be part of our parent chain, which means we have to number from here. Alright, so we get 6 carbons. 6 carbons is hexane. And then remember we change it to ene, so it becomes hexene. And the ene shows us the double bond. Alright, now we have 2 substituents. We have a methyl group here and an ethyl group here. Right, so the methyl is on carbon 3, so it becomes 3-methyl. The ethyl group is on carbon 2, so it becomes 2-ethyl. Now we just got to put it all together. Alright, so E comes before M, so it becomes 2-ethyl. 3-methyl. And then don't forget that we have to show where the double bond is in the hexane. So 1, and then we change it to hexene to show that there's a double bond. So the 1 tells you where that double bond explicitly is.